second part of the experiment, we're going to be looking at a chemical reaction. And for this one, we will be determining the heat of the reaction, delta H for the reaction, and it is related to the Q for the solution or water, like so. So on this one, this is where you have a reaction, and it could be endothermic or exothermic. Actually, most of your unknowns are endothermic, so we'll see that happen. The other thing is, when you do this experiment, the reaction isn't in a little box like this. You literally are just going to dump some salt in here and stir it and let it dissolve. So the reaction kind of takes place in the whole thing. And because you put the salt in and it's all mixed with the water, we will look at the change in temperature for the whole system. We'll call it the solution, which will include the water and the salt, and how much that changes. If this is endothermic, we're going to expect that the solution will cool as the reaction of dissolving takes up heat. Okay, so enthalpy, it's internal heat. It's stored in a chemical or potential energy form. It's not necessarily hot, but remember, enthalpy has to do with the substances and not the surroundings or what's happening with the water cooling. Okay, and you know, we do this little thing here where we kind of specify that pressure and volume are constant, just because we're not taking into account any changes as far as gases expanding or compressing, and that's not an issue here anyway. We don't even have a gas in our product, but we have to kind of make that assumption that all of the energy that is lost from within the substance is going to cool if it's going to warm if it's exothermic, or cool if it's endothermic. Anyway, and so I wanted to add a little bit of notes here. The word solvation means process of dissolving. In this whole thing, we refer to this a salt, and I just want to remind you that salt, of course, does not have to be table salt, but it could be any ionic compound. Remind you how salts dissolve. So salt, this is a solid. Ionic compounds are almost always solids, and when it dissolves, it ionizes. A few other things. If when you do your calculation, your heat of your reaction is positive, then is the reaction endothermic or exothermic? And in this case, the water would cool. This is a good thing to be able to associate these relationships, because on a test I sometimes just ask these, but it's a good way to check your work as well. Delta H is negative. That's for an exothermic reaction. It means the substances are losing energy and the water surrounding would warm. This again gives you a good way at the end to check your math. If your delta H comes out negative, you can say, oh, did the water warm? Oh yeah, I did. Kind of check your work. Okay, let's look at a problem. Let's see some numbers here. So I have the mass of the salt. I have the mass of the water. I have a T1 and a T2. Okay, and then it asked for the temperature change for the solution. So this is one thing we're going to do. The solution is going to be the water plus the salt. We're going to assume that the salt starts at the same temperature, like a room temperature, that the water does, and that they're all mixed together, so they're going to end up at the same temperature. So watch those positive and negative signs. Okay, we're looking for the heat for the solution. So this is our QS mat, and we're going to do everything for the solution. So this is where something's different. It tells us we can assume that the solution has the same specific heat as water. Okay, and then watch this part right here. The mass of the solution is going to be the salt and the water. So I'm going to plug in the 50, did those in a different order, but and the 2.60 grams. This is the water and the salt. Again, I'm going to keep a lot of digits here at first. Okay, so let's look at this. How much heat was lost or gained? So is this heat lost or gained? Well, it came out negative, so it should mean lost. And then we can rewrite that. When we see the negative, that means or lost. It's two ways, it's the same thing. So let's put that up here. I'm going to write it in the correct number of sig figs for my answer here though. Again, emphasizing that I don't use a negative there since it asks how much was lost. Lost takes the place of the negative sign. Okay, next step. So we're just going to take this and change the sign because the heat of the reaction is equal to the negative of the Q for the solution. So delta H Okay, and then this last one is a little tricky. We're just going to take this heat of reaction and convert it to kilojoules per gram. This is the amount of heat for the reaction that we did, but the temperature change that we got depended on how much salt we dissolved. So we're going to make it relative to that and also change it to kilojoules. So this is for the, how much did we dissolve? 2.60 grams salt we used. So when I start this part, I'm going to use this number with all the sig figs, or all the extra digits. That's how many joules per 2.60 grams salt. So that's the part that gets people. By the way, we're not doing this. So this was given the amount of salt that we dissolved goes there. So that's the tricky part. Then we can go from joules to kilojoules. Okay, and if you have these, those are old, let's get rid of those. You may not have them, depending on what class you're in. And that's it.